Hey, I'm Gautam and I'm an electronics student. So, my college told me to create a final year diploma project. Like everyone, I jumped straight to YouTube and started searching. Project list, instructables, ChatGPT, everything. But nothing really caught my eye. Then I remember our college workbench and suddenly an idea sparked on my mind. So I opened my notebook and started writing down every single detail, the circuit, components, and diagram that could make it happen. A few days later, I took a train to Grand Road. There, I bought all the essential components I needed to bring this idea to life. And once I reached home, the experiment began. And it was fun. I mean, yeah, it was. The first project was an XR2206 based function generator. I searched for DIY kit on Amazon and after a few days it finally arrived. I unboxed it, checked all the components, studied the manual and circuit diagram carefully. Then came the fun part, assembling it. I soldered everything and tested it on a DSO, and the output, perfect clean waves. Next, I decided to make an Arduino Uno based frequency counter to measure the signals from the function generator. The circuit diagram and code link were ready and everything was working fine. But I want to go deeper. So I came on ChatGPT and it told me to build a Smith trigger to convert sine waves into square waves so that the Arduino can read them. So I tried that experiment on a breadboard and checked the output on the DSO. Afterwards, I soldered everything on 0 PCB. But it didn't work as planned. Then I realized my function generator has common ports to control all the outputs. So I simply fed that square wave output directly to pin 8 of Arduino Uno. Problem solved. The only limitation was Arduino could measure only up to 250 kHz. But since it was a perfect beginner setup and I had less time, it worked. I did think of upgrading a PCIe based module which can measure up to 10 MHz. But with the time running out, I decided to continue with Arduino. Then Raspberry Pi Pico based oscilloscope. So again, I searched it on Amazon and bought one. Then I connect everything, uploaded the code, and it worked like a charm. A complete digital oscilloscope right on my phone. After that, I moved to fixed power supply using 7805 for 5 volt, 7809 for 9 volt and 7812 for 12 volt. I tested it. It worked, but not under heavy load. The ICs overheated quickly, so I replaced them with individual adapters. Later, built an LM2596 based variable power supply. Though the potentiometer didn't behave well, I made a small jugaad adjusted the wiring, and boom, it worked perfectly. Next was an Arduino Nano based component tester. But unfortunately, I lost the main video. But still, a few clips survived. Now it was time to bring everything together. I visited a shop to buy acrylic sheets for perfect housing. I marked, measured, and hard cut each piece carefully. And in between this, I got an email from Spotify for Rap 91 concert. So I went there just for, of course, Krishna. Luckily, my friend met Krishna. Then I came back and started designing the front part of the project. Then I started assembling the body, glued the panels together, added pads for safety. It was started to look really professional. The next day, I gave my friend the task to rub and smooth the side panels. And they did so well. But wait, what? Oh, wow. Now I started assembling all the front components. The display, banana sockets, knob and all. I placed every component carefully in position, soldered all the connections and started to finalize the wiring. Now it looked perfect. But later at home, I realized something was wrong. The wiring was a mess. So I removed everything and started from scratch again. This time properly. I even added a fuse for safety purpose. Then I bought OTG cable for the oscilloscope connection. I tried making a spring type cable inspired by Emirate crafts. But yeah, that turned out to be a total bullshit. So I made a small hole on the side panel and pass the wire neatly. That simple trick worked flawlessly. Next, I attached magnets to the top so I could remove the power cover and show the internal circuitry to my examiner. Another set of magnet was used for the OTG cable to stick it to the body when not in use. The result looked amazing. Then came labeling. Amplitude, fine, coarse, range, everything. And finally, I named my project ElectroMaster4X. After completing the hardware, I started working on black book, circuit diagram and PPT. Me and my team worked together. Not actually. And a big shout out to Ria, the real savior who helped us to edit our black book just a day before submission, while my friends were busy playing games. Then came the final day. After reaching college, I visited my friends' projects: frequency generator, smart fire truck, power supply. PLC controller, drones, gesture control car, robotic hand, and so many innovative creations. It was amazing to see everyone's work shining on display. This one is personally my favorite.
तो ये देखो 3 साल की मेहनत पहला प्रोजेक्ट आपने किया ये प्रोजेक्ट सर नहीं आपने आप आकाश किती मेहनत लागली यासाठी आकाश इकडे बघा जानाला काय बोलतोस यो मानसी शेवटच्या दिवशी पण अभ्यासच करणार कंप्लीशन करते तुम्ही डायला मी कैसा लग रहा है? बहुत मजा आ रहा है यार। रंजित कसं वाटतं शेवटचा दिवस आहे? खूप छान वाटतं तुला पण गेस्ट करेल जॉनी ओके थँक्यू सो कोमल कसं वाटतंय 3 वर्ष कशी गेले पटापट ध्रुव काय कमेंट देशील हो जॉनी आमच्या जीवनात आले आपली लाईफ भांगार जॉनी मी तुला खूप मिस करूंगी जॉनी यार तन्मय कैसा लग रहा है मौसम तो ऐसा लग रहा है दिल गार्डन गार्डन हो रहा है मी माझा असाइनमेंट कंप्लीट आई आइए अपने कॉलेज के एस्थेटिक बॉय मीटिंग है हां होली है साई काहीतरी बोल साई
बाबा तू हमेशा मेरे साथ रहे।
Later, I finished the few remaining parts. Now let's see how this works. component tester. This module can test LED, resistors, capacitor, transistor, FETs, inductor, and more. It has 3 terminals. Just connect the leads, press test. It automatically detects the component type along with all its parameters. Now a capacitor. You can see capacitance, ESR, voltage loss, and even terminal polarity. Simple, but it needs more modification in codes. Two fixed voltages, 9 volt, 5 volt, and one variable 0.5 to 12 volt output. Perfect for powering up multiple modules. Oscilloscope. I connected the OTG cable from my project to my smartphone and giving OTG access. The waveform instantly appeared on screen. Now let's test it live. I connected the function generator's output, attached the ground, and selected the square wave output. And there it is. Beautiful stable square wave on screen. You can see the frequency, adjust amplitude, and even change the waveform type in real time. Though the sine wave looked creepy here, on a real oscilloscope it worked absolutely fine. My project was also reviewed by a professional engineer with over 45 years of experience, the owner of an electronics manufacturing company in Mumbai. After analyzing my project, he smiled and said, "Great work, man, but you should also know the base of everything, the real working behind these." That line stuck with me. A lesson to always go deeper beyond just the circuit into the why and how. Finally, my black book arrived, and we were a bit nervous. It was a big day. The plan was ready, and the examiner came. Finally, it ends. But every end is a new beginning.